FOSDEM community, the history of NVIDIA and Linux. Then we'll talk a bit about the architecture of Nouveau, and then we'll conclude and do some nice demos, hopefully. So, today there are several Nouveau developers in the room. So, here we have Martin, Lucas, and Martin, but not the same spelling. I'm the first one. Also attending is Emil, right here. Francisco is here. No, we never met him. And Roy is here. Okay, and not attending are Ben Skaggs, the Nouveau maintainer, Marcin MLWK, our lead reverse engineer, Christoph Bermiller, the Gallium maintainer of the Nouveau driver, and many more people that you can meet on IRC. So the history of Nouveau, NVIDIA and Linux. First NVIDIA. So NVIDIA released the NV driver in about 89. I'm not sure. I think that's because of you that I find this number. Yeah. I'm not sure, but yeah, it was about this time. And then a few months later, there were the obfuscation commit. So they released the source code, but when after running the preprocessor, so it was basically unreadable. Okay, so this is the commit log for this. So I'll just read it. Sorry. After we already finalized X3, NVIDIA forced the X3 project to replace the sources we had with sources that were partly run through the C preprocessor in order to remove some of the names that NVIDIA thought might give away IP from. Okay, NVIDIA. This resulted in unreadable and unmaintainable code. It was, yeah, in 1998. It has been running for 7 years after. So just stop there. Okay, so they said they wouldn't support it in future releases, and yeah, it was kept for 7 years. So the history: Stéphane Marchesin, a French developer, decided to improve NV, and because he wanted to get 3D support in the Open driver. The project was named Nouveau because of a spelling mistake into his email client, automatic spelling correction, so before the iPhone. Got it popularized. Yeah, we backported, I said we, the community backported the NV update to Nouveau. In 2008, we got OpenArena running on NV4T, that's about GeForce 7. In 2009, we got the KMS driver, so that's the new architecture running on TTM and JM5 TTM. And we got merged into Linux in 2010. Then, a few months later, NVIDIA says, we won't update Visa anymore, so, not Visa, NV anymore, so use Visa or Nouveau. They did say. The return of the Jedi. So Andrew Fear, the software product manager, said in 2006 that it's so hard to write a graphic driver that open sourcing it wouldn't help. So in addition, yeah, customers aren't asking for open source drivers. Well, yeah, even without documentation, it did. Okay, so the architecture, and I'll leave Lucas to present this.
Yeah. So that's just a list of what chipsets we support in Nouveau today. It's starting at the Riva chipsets, which are really old. I don't think anyone has these chipsets in his computer anymore.
Not in my computer, in my closet.
Okay.
We still get comments coming though.
Yeah.
Yeah. So, yeah, then there are the different families what you can get together. There are the only 10 and 20 ones that are basically only fixed function and not really shadow-like. The GeForce 3 introduced that, but it's to modern standards non-usable. And yeah, then the GeForce FX and GeForce 6 and 7 series had real shader support, and yeah, we're working on them actively. Yeah, GeForce 8 and to Fermi is a roll other beast. We're trying to
Get it working.
get it working. Yeah,
It's a beast.
so a bit of hardware introduction to understand what we are doing here. All the NVIDIA GPUs are basically built from blocks called objects that are just spaces for registers where you can write something, and it belongs logically together. So you have the object, yeah, I'll tell it later. Yeah, command submission to the engines is done through buffers, DMA buffers. You basically put together the command stream on the GPU, put this into a buffer, and let the GPU execute it. Yeah, the GPU can access the host's main memory through a purchase, where you just map some main memory into the GPU's address space, so it can pull these buffers by itself. You don't have to get that. So, yeah, NV50, the GeForce 8, the original GeForce 8, added a full-blown virtual memory system. So they do paging. You can map memory through paging. No page faults like on the CPU, but yeah, you can migrate distinct pages. Yeah, there was big rework in TTM to support this. Yeah, and works pretty good now. Yeah, the important engines are also called objects. FIFO, that's the engine that's pulling all your commands. Then there are CRTCs that are basically doing the scan out from memory to your monitor. The biggest object is pgraph. Logically, it's the raw graphics core from these codes. All 3D commands go to this object, and it's basically OpenGL done in hardware. So that's one of the reasons we are pretty fast in implementing things after we have to reverse engineer it. It's simpler than on Radeon, for example, to do things, because yeah, you have the registers that are there and you stuff your OpenGL commands in there. Yeah. PMPEG, Martin will tell you about it, is a legacy engine only used to decode MPEG 1 and 2 videos. And then, yeah, there are several engines that were working together to decode newer video codecs. Yeah. Nouveau consists of 4 parts: the Linux kernel module, the libdrm with, yeah, it's fitted for Nouveau, the Xorg driver, and several drivers for 3D in Mesa. Here. Kernel basically does the resource management for us. It manage the GPU channels, where the NVIDIA GPUs have several channels that are switched by the card.
A channel is like a thread or a process, and so
Yeah.
every
A process.
every
So-
process can allocate
so
a channel.
Every rendering client we have gets a channel, submits its commands, and the GPU automatically switches between them to execute the commands. Yeah, like I said, memory management is done in kernel through TTM. Yeah, command submission. Yeah, the buffer, and then we do kernel mode setting since 2009. We don't have user mode setting anymore. And yeah, the topic Martin is working on is power management. It's going on for some years.
Yeah.
And we're getting somewhere.
Okay, so I'll just explain this and then we'll continue. So power management is a broad term for first understanding what's the configuration from the OEM, the vendors. So OEMs write the VBIOS, or at least some of it, some parts of it, and there are some informations like is there a fan connected, where is it connected, where is the temperature sensor, are there offsets, or this kind of things. Information to understand the hardware, because NVIDIA only, how to say, well, that's the chipset, but after you connect everything you want to it, but you need to say the driver, tell the driver how things are connected. Yeah, so first you need to understand the VBIOS tables. Then you need to calibrate the sensor, the temperature sensor. I'm not even sure that we are doing that right. That's a problem. Fan management, we'll talk about it later. Then the real power management, setting the clocks. So I'm pretty sure everyone knows what a clock is in a processor. Well, in a graphic card there are several ones. Well, in NVIDIA cards, the latest ones, there are more than 30 of them that you need to reclock, and doing it in the right sequence and so on. So it's really hard to reverse engineer this and debug it. It's not too bad now, but it took us more than 1.5 years to get it kind of working, at least on my laptop. Then, well, there's also real power consumption optimization, like clock gating. It's an hardware feature that allows to stop the clock if a part of the engine isn't used, so that it doesn't consume power. That's really good, and it saves a lot of power when, for instance, we are doing it on PGraph, the main engine. Yeah, PCI downclocking. It's, well, doesn't really matter, but it's always a matter of downclocking everything if it's not used, and upclocking it when needed. That's a problem. So the current state. So NVC0 is Fermi. We kind of know how to set the engine clocks, but not how to reclock memory. Memory is always really hard. Yeah, he worked on it. So
I know my own card, and I love it.
So it's black magic for the moment. We are still working on it. NV30 to NVC0, not included. We basically know how to reclock everything, even though NV30 doesn't really support reclocking. I mean, only a few of them have multiple performance level. So far so good, we'll say. Reliable clock changes, that's what I've been working on for 1.5 years. Works basically on GeForce 8 and 9. That's the only thing I had. And then the RAM configuration that has been mostly done by Roy has been going on for, I don't know.
Well, about 1.5 years.
Yeah, okay.
Yeah.
But yeah, it's getting done. It works well on GeForce 8 and 9. In the latest commits, or soon to be committed, we also have NVA3, so GeForce 200 up to Fermi, hopefully. So we need to debug that. Fan management. So yeah, it's not simple. It could have been, but no. So there are 3 kinds of fans. The first one is the to-go. It's on-off. So it could be simple, but yeah, not very good for hearing. Then PWM, it's when you, well, there are some registers to select the frequency of, I would say, you drive the fan, for instance, for 10 milliseconds, then shut the alimentation, the power supply for 30 milliseconds, and then get it back again.
Duty cycle.
Yeah, that's the duty cycle. So, well, basically for the user, it maps to a fan speed. So that's good for noise. And then the I2C device that is able to drive both toggle and PWM, but still you need to program it. And we are working with the HW1 subsystem, so as we can access everything from the kernel, because at the moment we can only access it from the user space through CSFS files, but obviously from the kernel you can't access that. So we're working on it. We've been working on it for what, a year?
Yeah.
Well, maybe more, because some people started working on it before us. Okay, and finally, performance counters. It's important to be able to know how much the card is used. For instance, there is a signal that we can monitor, that is pgraph used or not, so is it rendering something or not, but it could be also, is memory is accessed, and how much, so you can upclock when needed. And I think, no, that's not it, not yet. So work in progress, what we're doing right now is setting the memory clocks on NVA3, so GeForce 200 up to the latest one. Yeah, I have the laptop there, NVD9, but yeah, so for now it's not really working. We want to iron all the bugs on GeForce 8 and 9. Clock gating, well, we did some of the reverse engineering, but we are not sure we got everything right, so we need to work on this, but it's gonna save a lot of power. Fan management, yeah, not ready. We have kind of all the features, but we need to hook up to the thermal zones. I have a patch for that, but it's not merged yet. It has been maintained in the branch for, I don't know, 7 months, something like this. I still need to get on this. And yeah, dynamic reclocking. You'll see a demo of this. So, Forenix made an article a few days ago about reclocking. So Michael tried to reclock his well, the unsafe cards, but it worked for him, not the safe one. Okay, so that was strange, but it worked. So we can see that there is a performance improvement. It's not a lot. You'll see on my computer, it's a factor of 10 between the lowest and the highest one performance level. And you can see that compared to the blob is the proprietary driver, as we call it. We are not too far, about 10%, and we all go faster, I can show you. Not faster than the blob, I can't. But yeah, we're improving. And yeah,
Okay.
we'll improve thanks to this.
Yeah. So the second part, libDRM, it basically does our buffer management from the user space. So other things like our XOR driver or the MESA 3D drivers can rely on this. Yeah, it basically wraps around the GEM I/O control interface that's also used by the internet drivers, but we're interfacing TTM with this. Yeah. We have also some work in progress there. We are in the progress of rewriting this thing because too much of our API is stuffed into libDRM. So we are not able to upgrade the 3D driver without breaking something or compatibility with the libDRM. Yeah. It was designed with the NV40 class hardware in mind, so it doesn't really support the new features that we have available on GeForce 8 and other hardware else. Yeah. So exciting new feature what we'll get in the next time is a push buffer replay. It's basically a deferred context which is needed for DirectX 11 conformance. Yeah, we will be able to do that when the rewrite is done. Yeah, there's nothing much to tell about the Xorg driver. It works. For 2D acceleration, we do X video. Yeah, it supports the full range of devices that Nouveau supports.
Almost. The first NVIDIA card isn't supported yet.
I have another quite supported.
Yeah.
Yeah, and yes, it makes use of all engines to accelerate X. It works quite well. So our 3D drivers, we have two distinct approaches there. They are all using the shared infrastructure from Mesa 3D, but for the old cards we are using a classic driver which does only fixed function OpenGL, and it's only there to provide something to yeah, get things like GNOME shell or this working on this old cards. It doesn't do anything fancy. So yeah. Then we have three pipe drivers for Gallium. The NVFX driver for GeForce 6 and 7 class hardware, the NV50 driver for the GeForce 8 hardware, and the NVC0 driver for Fermi hardware. Yeah. Okay, confusing picture to show you what it looks like. The normal case for modern cards is that the application uses OpenGL, which is basically a state tracker in Mesa. You probably have heard of this. It all uses a common Gallium interface where, yes, all graphics functionality is abstracted, and under this there are the pipe drivers we're writing, which are utilizing the GPU.
So it means there is only one OpenGL driver that writes to the Gallium interface, and then we have the drivers that we can also call compilers that get the abstraction and send meaningful comments to the card. Yeah, basically.
Yeah. What we're doing, NVFX was one of the first drivers to use Gallium 3D. We jumped pretty fast on this, and nowadays it consists of two merged drivers, which were distinct before. And yeah, over the years it accumulated much old craft. So no one basically is able to do productive work on this driver without jumping through a lot of hops. So yeah, it also had no maintainer for over 1 year, so it's...
Do we have one now?
I'm trying to.
Okay. Yeah, he's working.
Yeah. Yeah. Work in progress. We working towards replacing this driver entirely. We have a new driver in the pipe which is basically modeled around the new driver model we seen in NV50 and up drivers, which we seen work well. So we are trying to get this hardware into this model. Yeah, new driver, NV50 driver. Yes, it's also an adaptive driver. The code base is formed by adapting the newer driver. We are constantly learning, and yeah, sometimes it pays off to just take the newer things and get it working with this. Yeah, maybe this will be the first driver to give you OpenCL in hardware. Francisco is working on this, and he will talk about this later today.
Yeah, that's
Really interesting. Yes, the work in progress there is not too heavy. We have a new shadow compiler almost ready, which has to be reviewed to be ready for merging. There are also the features that are needed for this OpenCL work. Yes, you should see this soon.
Oh yeah, and OpenGL 3 is not merged yet, but that's because we are waiting on the new libtrn to be merged. So yeah.
Yes. Next driver, NVC0. Yes, it's one of the first drivers to ship OpenGL 3. The maintainer of this driver has worked really hard to get this working before the rest of the stack was ready. So we're able to advertise OpenGL 3 with the release of Mesa 8.0. You see it here, just to prove it. Yeah, some work in progress as always. Christoph is working to get new OpenGL features ready. He's also working on some DirectX 11 features.
I think that's the next line.
Okay.
Yeah.
Yeah.
So
Okay. Yeah. Yes. Francisco is working on OpenCL. It's sponsored by the XWork Foundation. Yes, it's very experimental today. There are some parts missing altogether. You have to write your kernels in TGSI, the immediate language for Gallium.
If you don't want to, if you don't know what it is, you don't want to touch it.
But
You'll have the presentation at 6 if you're interested in.
He's writing an LLVM backend to support this. Yeah. Okay, don't talk about this. Yeah. D3D1X is also a state tracker of Gallium. Yeah. It was started by Luca Barbieri. He dropped the code on us and disappeared after this. So this got a bit rotten in the meantime. But yes, Christoph now actively uses this code to get features in the NVC0 driver ready before the other parts of the stack are ready to support them.
Yeah, that's
so
why
that's why he's working on it a bit. Yeah. The Heaven benchmark works through Wine with the state tracker plugged in as the DirectX backend. But most applications do simply crash.
I think all of them.
Yeah.
Except this one.
Except this one. But
yeah, that's an amazing one. So that's why he was able to advertise OpenGL 3 so fast. It's because he tested it with DirectX 10 and 11 before. He tested the features on DirectX 10 and 11 before. And he also asked me to tell you that if there are some game developers in the room, do use OpenGL 3 now, please. Because he needs, obviously he needs some test cases.
Yeah, video decoding.
Yeah. So I've been working on Nouveau since like last July. At first it was like someone was, I think it was Christoph who was like, yeah, we need someone to work on it. And then I was like, okay, I'm interested. And I didn't know anything at all about Nouveau at that time. So I started working on it. At first I've been working on PMPAC. PMPAC is the first engine that NVIDIA ever created. In the first GeForce 4, they had like a fully working MPAC engine, except it still needed the CPU to do some parts of it. And later on they removed some of the features and they started introducing the newer engines, and they're the bitstream processor, the video processor, and the post processor, and that post processor was also added later. There's still a lot unknown about this at the moment, so I can't tell you everything except the things I do know, and some things I might have guesses about, and some things I may not know, and may be guessing wrong. But so, video decoding. Why do you want to do it on the GPU? Well, the only reason is because unless you have a very fast CPU, if you want to decode 1080p, you will not be able to keep up. So you need a fast processor, or you need to do it in hardware. So what NVIDIA does is they have the hardware, and they just have created an engine so that they can decode it for you. And also the lower power consumption, because if you do it on the GPU, you don't have to move as much data around, so it can be quite a lot faster. Because the bit stream is a lot smaller and it uses less bandwidth. Plus it's optimized because it's specialized hardware, so it can do those things really fast. So I've talked a bit about PMPAC. There's really not much else to say about it, except that was the first thing I talked about. I think someone here was working on it and tested a bit, but not much. And of course the interesting things are the newer engines. The bitstream processor, the video processor, and the post processor. They were introduced later, I think 1998 the newer hardware has them. I think from at least and I've been working on GeForce for GTX 400 and higher further. So that decodes most video streams. So basically this is the result. I have a bit of MPlayer behind. I was still figuring things out, but that's basically MPAC or Part 10 working on Nouveau. But it's still incomplete because I've only managed to get it working with the firmware that NVIDIA already has. So if I upload that firmware to the hardware and then run a few commands, I can get it working like that. But there's also a part that's more generic, and that's the part after it's decoded. You get a set of images, and those images need to be, they are in a different color space than what is presented on your screen, so you need to do all kinds of crazy graphics transformations. Fortunately, you're on a video card, so that part can be done generically, and that's basically the other part that I've been working on. That's basically to get a few shaders, to get it looking right, to do color space conversion, to make it not look like crap in MPlayer, etc. And that's independent of codec, so well, the bitstream engine, etc. all depend on which codec you load. This is really generic, and I've also been testing it on Gradient drivers when I didn't have anything else to test on. That's it, the car is working. So that's basically all I know about video decoding at the moment. I could go into specifics, but I don't really know when I have all the information to get a really working open source version of it, because some part of it is still a black mystery.
Yeah, so it's been worked on for several months by our reverse in chief, really. And yeah, it's basically there are loads of assembly code with different.
It's not just assembly code.
Yeah.
It's also that some of the instructions do specific things only for a specific codec, and you don't know in advance what they are. And it's really assembly that's also made for specific hardware, because a whole lot is done without us knowing about it. So it's a bit of black magic. So it's a work in progress without documentation.
Yeah.
But we're getting somewhere.
So if you you come to the Nouveau channel and you see some stuff in the commit logs that you don't understand, it's probably something related to video decoding.
Yeah. Also probably when Master is swearing, it's also about that. Because it's really that insane. It's not even insane architecture.
yeah, that's a conclusion.
Yeah, I think that's your part.
Okay, yeah, and then now I'll do the demo.
Yeah.
So finally, why Nouveau? Why should we invest so much time when the blob is kind of working? Well, it's working not too bad. Well, first because the blob doesn't support all cards, so you can't use the latest Xorg server, X server with old cards like before GeForce 7. That's not what we want in open source and an open source operating system. Also, we want to develop new features like kernel mode setting, xrender that is only partially implemented in the blob. There is also Wayland that is soon to be discussed, and yeah, DirectX on Linux. Isn't it great? That's crazy. It's never going to happen on the blob, but yeah, it's fun. Also, there is the plug-and-play support. You just put the card, boot, it works. Wonderful. No need to install and maintain the blob. And of course, for fun. It's really interesting. You learn a lot about the hardware by doing reverse engineering. That's also crazy because reverse engineering, something you know nothing about, is kind of hard, but yeah, you get your way through, hopefully.
Also, it works on X Server Master if you work on X and accidentally bought a laptop with an NVIDIA GPU, hypothetically. Thank you.
Okay, so we'll move to the demos.
I got a question about NVIDIA Optimus video card. Will they maybe be native supported by Nouveau drivers in the future, in combination with Wayland?
We certainly hope so.
Yeah.
Sorry, can you repeat the question? Optimus.
Yeah. Okay.
Yeah, Optimus support on Nouveau.
Yeah.
Well, at the moment there is work on it. I think David Early is working on it, and when he's working on it, it's always with Nouveau plus Intel.
Yeah.
So, well, I can't tell you more, but it's being worked on. I don't know, I don't have a time frame for it, but
Yeah. It's
it's
basically much hex to know. Yeah, the X server will need some re-architecture to get this working. So
I don't know if
don't
Wayland is an
expect
option.
it soon.
I think this question belongs to this part of
Okay.
Right
behind
behind
all
you,
developers.
there's the DMA buffer sharing guy.
We are all students here. So,
Yeah, the Nouveau and Intel parts are the easy part. It's the X server part. I don't
Yeah.
envy Dave's work
Yeah.
there. God, that's a mess.
Yeah, I think so.
I've taken I took a couple shots at, essentially you need to get the X server to understand screen GPU hot plug.
Yeah.
Because that's what it looks like. It looks like adding a screen rec and doing all this other stuff to it. Sorry, adding a GPU and doing all this stuff to it. And that's not a thing that we were considering doing in 1989 when this whole pile of crap descended from heaven. So it's really invasive. It's essentially just demolishing the entire API, and you would have to port every driver you care about.
Yeah.
That's not a small amount of typing. So I am very, very happy that Dave's working on it, because he's done a lot better at it than I have, but I wouldn't be holding my breath.
Yeah.
Call it a year.
Okay, thank you. Yeah.
well, before, anyway, Nouveau isn't doing good power management at the moment, so it's not a good idea.
Yeah.
But hopefully by then we'll have it.
You never know.
So what's the status? I know you got a demo, but how fully do you support the different display configurations of the NVIDIA stuff out in the wild? I mean, is your display port
Oh, I think
full?
all
Do you
of
have
them
HDMI
are,
audio?
They should all be
Yeah.
supported right
Yeah.
now.
yeah,
So-
even HDMI audio. It was worked on, I think, a few months ago, so it should be in Linux 3.2 or 3.3. I don't know. That's always the problem when you develop on a private tree. You're not synced with Linux.
Just from like watching, Ben's been doing a lot of work on decoding more bits. They have an actual connector table. You guys should look into that.
Sounds cool. We should have one of those.
It's, yeah, every once in a while it describes things like, oh, this is DMS 59, and you can split out 2 ports from this instead of just 1, and they need to be, 2 connectors instead of 1, and then you add little bits. But it's only features of like, oh, that one card added something new. For the most part, it's pretty awesome. So thank you guys. It really works really well.
So demos, we'll demo 2 things. Well, actually 3. So first, MPEG video decoding. Oh, yeah. So the kernel side is done. It has been merged in Mesa 8. Yeah, it should be merged. Yeah. Okay, great. So when Mesa 8 is released, you'll be able to use this. Well, if you want, because it's useless. But
The real problem is that it costs so much CPU to get it right with the later versions of PMPEG that you really get a little benefit out of it, and because the CPUs who can do it already can do it in software as well.
But I found a case where it works better, and I'll show you that. Yeah, so, but anyway, MPEG 2 is DVDs. DVDs can be decoded, like, yeah, even in Atoms or ARM, there's no problem at all. It's too small. And then reclocking, so we also the benefits of reclocking, the performance improvement that we can see in Nexus and OpenArena, if we have time. Also in XVMC, so when we are using PMPEG, and dynamic reclocking, that will be the end. Should be stable, but yeah, and so put it at the end just in case. Okay,
unfortunately, we cannot demo the VD-POW stuff because we couldn't get a laptop ready for that in time. It only works on specific hardware.
Oh yeah, we don't have the hardware in our laptops, so. Please. Sure.
Yeah.
Oh, great. So we'll start with a benchmark using Amplia. So it's 2, yeah, 1. I made it simple, should be. So this is a benchmark using Amplia, benchmark. So basically it tries to draw everything as fast as possible. So you'll see the result. It's not pretty. So using XV first. So the current acceleration method. So it stalls. That's the only DVD I had, sorry. Okay, so not good. Oh, please, yeah. So, oh, many errors. Wonderful. So then we'll try with XVMC. No, didn't get it. Up. Oh, that's me. Very good. Up. So that was video decoding. Sorry, really, that's the only hard one we had. If we had a Fermi laptop here, we could have done it for VDPO, but yeah. Okay, so we'll move to power management. That's going to be difficult. Okay. So, power management. Where is the... Okay. So at the moment, when you want to get information about what perf level you're on, or anything, you get in... Well, wonderful.
It already crashed.
Yep. So, wonderful. That's the new kernel. I don't know why LC1 is not stable. I shouldn't use it. But you find this. So, it says that you have 128 megabytes of VRAM. It's GDR3. Just for the records, it took us, I don't know, 2 weeks to get the information about the memory type, and we didn't find it. It was the Nouveau maintainer, Ben Skaggs, who found it in 1 day.
Yes, lucky.
No, he wasn't lucky. It's really good. So after that, you can see that there are 3 performance levels. The first one, core, is pgraph. Shader is twice pgraph speed. And then it's memory. So the first perf level is at 100 megahertz, and then yeah, at the highest perf level, so perf level 2, you have 600 megahertz. Very good. You have the voltage and the fan speed, but you shouldn't trust this because NVIDIA tells us to do stupid things, like the fan speed all the time at maximum. Yeah, they are doing temperature-based fan management. It works for us, but yeah. So then you have the C. What does C mean? It's current. Current. Well, that's fun because it maps to this path level. That doesn't always work. So sometimes we have some strange settings, really stupid settings. But yeah. So
Clock
we need
speed
to
is different between those two lines by 1.
Yeah, that's actually because there's difference between the VBS, what they want us to write, and what we can physically write into the PLLs. So yeah, the difference isn't really there, because if you try to put the performance level 1, you'll get exactly the same thing.
Is there a hardware-based throttling that occurs if you go over some thermal trip point, or can you just fry your card if you want to?
It's there, but it's not supported. That's the problem with the hardware monitoring. You cannot see it from the kernel space.
You can't, but so it happens, so you won't damage your hardware, but you can't control it. That's okay.
No, no trip points. We have to find, well, that's the trip point. It's in the VBS only, and we need to set the clocks accordingly. It's not in the hardware. We say go to trip point 1, trip point 2. No, it would be.
No, I meant say you run it at 400 megahertz, clock the shaders to 800, clock the memory to 600, and run the fan at like 1%. Will it?
Could do this. Yes.
Will the hardware thermally throttle you, or will it
No,
clock
no,
throttle
no.
you? So
you'll
just burn it out.
Yes.
Okay.
Yes, but you can.
Yeah, but I've been trying to, and I can assure you it takes time.
No, but
Oh yeah, no doubt. I'm just curious.
There's
Like,
also-
on the Intel stuff, we tend to be paranoid about our silicon, so we have a lot of hardware clock throttling that occurs. So it's hard to actually physically damage it. But
Well, on NVIDIA there's also a separate daemon that's also an engine, and you can upload whatever to it, and it can execute with the same levels as the kernel. So it can also be used to monitor the fan speed and just go up it.
And temperature and so on. We want to do that, but it's only available on later cards, GeForce 200. Yeah, I'll get to you working this. Okay, so now the demo part.
It's also why it's not released, because you can burn up your card if you're not careful.
Yeah, so you can access everything through C's class DRM card 0 or 1, depends on, of course, how many cards you have plugged, device. And then in this, there is one file called performance level. That's basically what is what you have seen in the DMSG. So we'll change the performance level, but first I want to show you GLX Gears, the famous performance test suite. It's here. So yeah, okay, about 500 FPS. That's slow. Up. So we'll down clock first. So echo the performance level you want. Okay, taps. The performance level you want. You write it to performance level. No, it didn't crash. Whoops. I was afraid.
You're keeping track of the current performance level here below.
Yeah, for the demo of dynamic clocking. You'll see it. Okay. I was getting stressed. GLX Gears, so we show it just in case it changes performance. Wait, what? Actually, you'll see it's still performance level 1. I don't know why. I want 0. Too bad. And it doesn't. Okay, let's try 2. That's the first time it doesn't want me to. What the? Okay, let's try dynamic. Hopefully this will work.
Oh, maybe because you're not on
The what?
the mouse, right?
Well, we'll see. Okay, so reclocking. Oh, I think I know what's the problem. It's because of the kernel and taking some locks, and maybe that's why it fails. Maybe. Okay, so next time. Yeah. I
External
rebased this.
display, maybe?
Hmm?
External display, maybe?
No, that's not the problem. That's for sure. Oh, look, I can't even type now.
Reclocking failed.
Reclocking failed.
Yeah, that's our engine to reclock. Well, it failed. That's the first time I did without ever trying to get it to crash. Usually it takes me time.
Because you're giving a demo.
Yeah. And maybe because of the kernel, that is, strange. On both my computer actually, the same crash. So, okay, sorry.
If you're ready for questions, this is a video question actually. The bitstream processor and video processor. How general are those? Like, are they tuned for MPEG, or could you reasonably do like PP8?
No, you cannot do PP8. It's all done in silicon.
Okay, so but it's not. I can imagine like a bitstream unpacker where you feed it. Oh yeah, this is how you unpack these bits. You feed a little program that says how you unpack things.
No, it's all done in hardware. The only thing the software does that runs on those engines, and that's the part, the firmware we have to upload, is the part where it processes the first slice, the slice header, and all the rest, the data, is done by the hardware itself, and you don't even know for sure what it's doing. It just gives you a return if it's done or not.
Okay.
So I was thinking the same thing, but PP8, all those things are just so codec specific that it's really impossible to support probably. Maybe if we have more info, we can do the non-bitstream acceleration parts, but at this point it kind of looks like there's so many very specific things, I don't know if it's even possible.
Okay. Just maybe I want to finish on power management. So what was supposed to happen was after going to performance level 0, GLX gears went from 500 to 100 FPS, and when on the highest perf level it would have gone to 1600 FPS. Then I would have shown you NextWiz up in Arena and having about 100 FPS, so that was good. And I wanted also to show you that we have two settings, one for the when you're on battery or on the sector, so as you can do automatic things when you don't want to have automatic reclocking, when for instance it's not stable to reclock. Like this case, but this one is supposed to be the best laptop for reclocking. Yeah, I've tried to reclock 1,000,000 times in a row and it worked, but now I'm just trying once and it doesn't, really. Okay, so that's what it is, and yeah. So any more questions? Yeah, there are two.
I had a small question about working on some feature cards, like quad buffering or stereo video. Because why I'm asking, because some NVIDIA has many lines of cards, and the only difference between some cards and others is just device ID. Then for example, checkers cards which represent like equations, they only modify the device ID and say in this line we support quad buffering processing. I'm asking, are you working on that, develop that feature?
To put it short, we're trying to work everything what's on the hardware. So we're not respecting any of these artificial limitations that NVIDIA put there. So,
and actually at one time there was something a bit like this, physical limitation, software limitation, but you had to, actually the manufacturer had to put solder blob somewhere and it would activate some features. But we could override this from the software and from the driver, and so we did, if I remember correctly. So on some cars you get a quadro for not too much.
yeah.
But it's right, every time there's a feature that is implementable in the hardware, we try to use it.
Yeah, I have two questions actually. The first is kind of a newbie question, and the second is about power management. The first is I've never used Nouveau before because I've been buying AMD GPUs since they did documentation releases. But I'm fully in support of the project. It's really important to have FLOSS drivers available. And I'm wondering if, because when I use the Radeon driver, I need a proprietary firmware blob to do acceleration. And I'm wondering if there's any generations of NVIDIA hardware where you also need a proprietary firmware or microcode blob to do any features, or is it all completely 100% FLOSS from top to bottom?
There's one card that needs it. It's NVT9. It's the latest one. But
The latest one?
Yeah.
Fermi or?
Yeah, the latest Fermi.
The latest
strange
Fermi.
version of Fermi, but yeah.
Yes, to put this in context, we have had blobs we had to use to get the acceleration running, but we're always trying to remove them. And yes, for most of the cards we have free software replacements of those microcodes. Yeah.
That's also why I'm not releasing any of my stuff, because mostly it's because we don't fully understand it, and just putting in the blobs is not going to help us any. And you have still to download them, so that's going to be a bit messy.
Okay.
Yeah. The shader part is already built, so you can only use part of it.
That's nice.
And
And the second question about power management is, you mentioned earlier before that the main GPU, I mean, my understanding of it is the GPU has a factory clock and then the RAM plus has a factory clock, but you mentioned there's 30 different parts or so of the GPU. That I don't understand this. My idea of it is the GPU is a processor. It's maybe a simplistic view, but like you reclock the GPU to a certain thing. What is this about reclocking different parts of the GPU?
like those engines where you had like you had the graph engine and you had a whole bunch of other engines, just like the shaders are a separate engine.
Okay.
So those all need to be clocked separately, and you need to do it in such a way that the card won't crash.
Okay. Yeah. Actually, there are two clocks signals. One from a crystal